All right, let's dive into a world where computers don't just follow one instruction at a time, but instead they can explore every single possibility at once. This is the wild world of quantum computing, where we take these strange, counterintuitive rules of quantum mechanics and use them to build machines that could literally change everything. So, here's our roadmap for today. First, we're going to get into the absolute core building block, the quantum state. Then, we'll see how we can actually take all this quantum weirdness and control it. After that, we'll look at a really cool search algorithm that shows off this incredible speed. And finally, we'll explore why any of this matters, the real-world problems this tech is ready to solve. To really get our heads around this, let's start with a little thought experiment. Just imagine a super complex maze. A normal computer, it would try one path, hit a dead end, backtrack, and then try the next one, and the next, one by one. But a quantum computer, well, it takes a completely different approach. And this slide just nails that core difference. On the left, you see the classical computer, just grinding away one path at a time. But on the right, the quantum computer is exploring every single path, all at once, in parallel. It's not just about being faster. It's a totally new way of problem solving. So you gotta be asking, how is that even possible?
Well, to understand how a computer can check all those paths at once, we have to look at its most basic part, the quantum state. This is really the bizarre but powerful heart of the whole thing. The secret ingredient here is a property called superposition. You see, a classical bit, the ones and zeros in your phone or laptop, is always either a definite 0 or a definite 1. It can't be anything else. But a quantum bit, or qubit, can be in a combination of both 0 and 1 at the exact same time. Think of a spinning coin. While it's still in the air, it's not really heads or tails. It's kind of both. To make this a bit more real, let's think about a strategy video game. Normally, you have to choose, right? Are you going to attack or are you going to defend? You have to pick one. But in a quantum world, your strategy could exist in a superposition of attacking, defending, and using stealth, all at once. So here's the bottom line. The classical way is slow. You have to evaluate each move one at a time. The quantum approach, though, evaluates the entire strategy space simultaneously, how attacking affects defending, how stealth changes the odds, all in one single go. It's only when we decide to look for the answer that the system settles on the single best outcome. Okay, so we've got this incredible property, superposition. But how do you actually control all this weirdness to get it to solve a problem? Well, for that, you need a very special toolkit. And that toolkit is made of something called quantum gates. You can think of these as the fundamental instructions, the building blocks for any quantum program. They're what let us precisely manipulate the state of our qubits. This is a perfect way to think about it. A quantum gate is like a really sophisticated dial. It doesn't just turn a qubit on or off. It can rotate its state, tweak its probability, and even do something mind-bending, like linking the fate of one qubit to another. That's a property called entanglement, and it's a whole other level of weird. So, when you arrange these gates in a specific sequence to solve a problem, what you get is a quantum circuit. This is basically the blueprint, the step-by-step recipe that tells the quantum computer exactly what to do to get from the problem to the solution. All right, let's see how all these gates and circuits can be put together to do something truly powerful. We're going to look at a famous algorithm that really shows off the incredible speed-up quantum computers can have over the ones we use every day. So, picture this. You're trying to find a movie on a streaming service with millions of titles. You can't remember the name, but you remember a few things, like it was a sci-fi movie from the 90s about an AI rebellion. A classical computer would have to check its database item by item, super slow and inefficient. But a quantum computer running something called Grover's algorithm is way, way smarter. First, it puts every single movie in the database into one massive superposition. Then it uses a special oracle function to basically mark the correct movie, the one that matches your description. Now here's where the magic really happens. Another operation comes in and amplifies the probability of that marked answer while shrinking all the wrong ones. You repeat that process just a few times, and when you finally measure the system, it collapses directly onto the movie you were looking for. And this chart, wow. This just shows you the mind-boggling scale of the speed-up. To find one item in a million, a classical computer could need on average 500,000 tries. The quantum computer, it needs only about 1,000. That is a truly game-changing advantage.
So, a faster movie search is pretty cool, but this kind of power has implications that go far, far beyond entertainment. Let's look at the truly world changing problems that this technology is really poised to solve.
The potential applications here are just staggering. We're talking about things like unhackable security, designing new life-saving drugs from scratch, creating vastly more powerful AI, and optimizing global financial markets. It's not just about doing current things faster, it's about solving problems that are basically impossible for us right now. Take cryptography, for instance. Using quantum principles, you can create communication channels where any attempt to listen in is instantly detectable. Think about it like sending a sealed letter that changes color the exact moment anyone else tries to read it. Your data security would be guaranteed.
Or what about medicine? Designing new drugs is incredibly hard because molecules are quantum systems themselves. Even our best supercomputers can only guess at how they behave. But a quantum computer could simulate those molecular interactions perfectly, opening the door to designing brand new medicines and materials from the ground up. And this visual really captures the potential impact on AI. A lot of AI problems are what you'd call optimization problems. It's like trying to find the highest peak in a massive mountain range of possibilities. A classical AI might get stuck on a smaller peak, a good enough answer, but a quantum computer can survey the entire landscape all at once to find the one true highest peak, the absolute best solution. This could totally supercharge machine learning.
Ultimately, what we're looking at is the dawn of a new era of computation. This isn't just about getting answers faster, it's about changing the very questions we're capable of asking in the first place. The problems we once thought were unsolvable might soon be within our reach. So the real question isn't just what we can do with quantum computers, but what new worlds will they allow us to imagine?